For question 2 on this sheet, we're asked to sketch two equations, this one, and we're asked to sketch them on the same graph, and we're asked to show the coordinates of any points of intersection with the axes. So I've drawn myself a set of axes. It specifies here these are going on the same axes. We're going to start off by sketching this one first. So this is a y equals x squared graph. If I was to cover up this and this, it would reduce itself to x squared. So this is an x squared graph. This replacement here of x minus 4 with x is going to mean it shifts along to 4. And this plus 2 on the end means we're going to be moving our graph up 2. So the bottom of our graph is going to be here. And this, because it's an x squared graph, is going to go out like this. And it's going to go out like this. And there's our y equals x squared graph. We're asked to find the coordinates of intersection with the axes, so we need to find this one here. We do this because this has got an x coordinate of 0. By putting 0 in here, we get minus 4 times minus 4, which is 16, plus 2, which is 18. So we've got that point. We're also asked to sketch this graph here. This is has a y-intercept of 13, which is about here. Doesn't have to be perfectly to scale, but just needs to be roughly correct. This has got a gradient of minus 2, which means it's going downwards. We need to work out where it intersects. If it intersects here, it's not going to cross. If it intersects over here, it's going to cross. So 0 is 13 minus 2x. 2x equals 13, x equals 13 over 2. 13 over 2 is 6.5, so that's over here somewhere. So we need to connect our line. So our line goes from here all the way through this point here and back off there. So this point here is 13 over 2, 0. And this here is 0, 13. So I've marked on all my coordinates, I've got my graphs. So that's the end of part A. For part B, we're asked to connect these two things up. So we're asked to solve x minus 4 squared plus 2 equals 13 minus 2x. You'll notice if I bring back the sheet that we're only asked to solve. If we solve, we're going to get this point of intersection and this point of intersection, but nowhere in here does it specify we're asked to find the coordinates of the points of intersection. So we only need to find x from this. We don't need to put it back and get y. So in order to solve this, I'm going to expand and collect up all the terms. So I get x squared minus 4x plus 2 is 13 minus 2x. This leaves us with x squared minus 4 plus 2, when we bring this over, gives us minus 6x. And then we've got our... oh, we missed our 16. Plus 16. Sorry about that. So we've got our 16, our plus 2 is 18. Subtract 13 gives us plus 5 equals 0. So now we've got x minus 5. If we factorise this, x minus 1 equals 0. X equals 1 or 5. As I said before, we don't actually in this case have to find them, but here is 1, here is 5. It's this point and this point. We could if we wanted to find the y values, but we're not asked to do so. In part C, we're given this inequality. So we're given this inequality here. This will recognise as our curve, and this is our line. So for part C, we're asking where is the curve less than the line. If we look back at our diagram, we'll see the curve is underneath the line here. So all the points between 1 and 5, the curve is underneath the line. So our answer for the last bit is just 1 less than x less than 5. Which we can do without any working. It's a 2-mark finisher to this question. It is hence, so we're going to use what we've already found, and that's our answer for the end of 2.